In this lecture, we will see the approaches for minimizing leakage power. Actually, it has broadly classified into two types. One is standby leakage reduction. Another one is runtime leakage reduction. Yeah, in case of standby, what is the meaning of this standby? So at the time, what will happen? This changing of inputs are not going to be taking place. Of course, the clock is going to be withdrawn. So at that time, we will have only the leakage power dissipation. But whereas coming to the runtime, that is nothing but the dynamic, we can say. So at that time, there is going to be changing the inputs as well as the clock also is going to be operates. So automatically what will happen, we will have two types of power dissipations. One is the dynamic power dissipation along with the leakage power dissipation. So here in case of this standby leakage reduction, actually we have some techniques. The first one is transistor stacking, variable threshold voltage CMOS, that is the VT CMOS. Next, multi threshold voltage CMOS, that is MT CMOS. Now we will see this transistors stacking. So actually, if you will see, I'm going to be making use 4 PMOSes in parallel mode, 4 NMOSes in series mode. Here some of them or maybe input, it may means particularly here some of the transistors input may on, or maybe it is going to be in off mode. Let me consider that all 4 inputs are going to be in what is that off mode. So automatically what will happen here, even though I'm going to be making use 4, okay, what is the total number of combinations? That is 2 power 4, means totally I will get 16 combinations. Okay, so here let me consider that I'm going to be applying only for here some of them is going to be here. Let me apply 1 for the PMOS. Automatically what will happen, it is going to be in on mode, NMOS is going to be in off mode. Even though it is in off, okay, there is some leakage current flow, okay, because of a small sub threshold voltage. So it leads to the sub threshold leakage current. Okay, so because of when you, even though it is going to be off, okay, we will have sub threshold leakage current. So the number of transistors give how much leakage current is going to be taking place over here. By applying the suitable, means how we can overcome this problem, by applying the suitable combination, the leakage current can be reduced. For complex circuits, okay, there are so many inputs, okay, so the combination, or let me, it is going to be some 50. So automatically what will happen, the number of combinations is going to be 2 power 50. So it is a complex, or it may take large time to fix which one is going to be a perfect combination. Okay, so at the time usually what we will do is, okay, we are going to be giving randomly some on and off, okay, to generate the input vectors to the circuit. Okay, the power dissipation is going to be reduced. That input sector vector we are going to be making use, which is going to be suitable for this. That is the technique we are going to be making use in case of this transistor stacking. The next one is, okay, we have a variable threshold voltage CMOS. Okay, so here if you will see, we are going to be making use, okay, suitable bias control circuit. Okay, so here if you will see, actually when we are going to be applying the body bias, okay, but means before going to that, let us see, okay, it is going to be operates in active mode as well as standby mode. Okay, it is going to be 2 volts here, it is going to be 4 volts here. So here 2 volts and 6 volts, here it is going to be 0 volts and minus 2 volts, here it is going to be 0.2 volts and it is going to be 0.6 volts. Okay, so in this case, as threshold voltage is going to be increases, okay, threshold voltage is going to be increases by 4, okay, the sub threshold leakage is going to be reduced by 1 by 16, means 1 by 16. Okay, so here you can see, as for every what is that 100 millivolts increases, okay, it is going to be half. the leakage is going to be half. So here it is going to be 4 times, it is going to be increased. So automatically what will happen, 2 power 4, that is nothing but 16. So 1 by 16, okay, the leakage current is going to be reduced automatically. Here if you will see what will happen when we are going to be making use this, okay, apply body bias to reduce the leakage current when it is in normal mode. The circuit is going to be zero body bias. When we are going to be making use in operation, apply the reverse body bias, okay, the threshold voltage is going to be higher, the leakage current is going to be reduces. But one and only the problem here what we have is, when we are going to be introducing one more peripheral device, automatically what will happen, the area is going to be increases. Okay, so the circuit, it may become complex. More than that, nothing else over here. Okay, now we will see the another one, that is the multi-threshold CMOS. Okay, so in case of multi-threshold CMOS, actually here we have SL and SL dash, that is nothing but sleep control signals. Okay, so here if you will see, this is going to be the PMOS with the high threshold. Okay, this is NMOS with the high threshold voltage. Okay, but in between we are going to be making use, okay, low threshold CMOS circuits. Okay, when we are applying this SL to both, okay, one is going to be complement with each other, because this is SL and it is going to be SL dash, so it is going to be complement with each other. In normal mode, both are going to be on, both are with high threshold voltages, both are going to be high threshold voltages. So the flow of current will be depends upon this. When it is going to be in active mode, both are going to be off. When it is going to be in standby mode, okay, high threshold transistor is alone, okay, means it is going to be high threshold transistors are going to be in series with the low threshold voltage circuit, which reduces the leakage current. Okay, because even though it is going to be high, when it is going to be passing to this, automatically what will happen, the threshold voltage is going to be reduced, because it is going to be low threshold voltages. So leakage corresponds to high threshold one, and performance is belongs to low threshold transistors. So this is the advantage of what here we have, and this is the technique which we are going to be making use to reduce the, what is that, leakage power. Okay, thank you.